Hello, my name is Samiksha Sarnaik, roll number S190953059. I am here to present you data analytics oral answers. We were guided by Harshali Mane ma'am during the academic year 2020-21. Our outline will be, first of all, the question number one that I got was pre-processing operations. Question number two was characteristics. I have to explain the characteristics of good data model. Question number three was related to cumulative distribution function. Question number four was we were asked to choose the topic and I choose data visualization, in which I explained matplotlib, Seaborn, and pandas. Also, in that, I explained histogram, bar graphs, and scatter plot. Also, at the end, I mentioned the references also. Question number one was normalize the data attributes of the IRIS dataset from sklearn library, display the data, and perform the pre-processing operation of normalization and scaling. Here we are asked to perform scaling and normalization on dataset IRIS. These are pre-processing techniques. Generally, data in real world is either incomplete or has noise in it. So pre-processing technique involves transforming the data into understandable format so that we can make most out of it. In normalization, we adjust the values of the columns on a common scale without distortion. Scaling is transforming data so that it fits within the specific limit like 0 to 100. So let's move to the coding part. Here first of all I normalize the data attributes of the IRIS dataset. For it, I first from sklearn dataset import load IRIS. This means I was importing IRIS from sklearn datasets. Then I also imported pre-processing from sklearn. Now what I did is I loaded the IRIS dataset into the key into the variable IRIS, and then I printed the IRIS data shape. IRIS data shape is a function iris.data.shape. It gives the length of the corresponding array dimensions. Then what I did is I separated the values, that is I separated the data and target, that is x and y, and then I printed and then I normalized the value. I normalized x, that is I normalized the data. So what I did is I used variable normalized dot underscore x is equals to pre-processing dot normalize x, and then here here what printed answer is, it is of iris dot data dot shape. Now what I did is I first of all printed the iris data set, and then here, and then I printed the normalized value of the normalized x. Okay, this was the first part of the first question. In the second part of the second question, I standardized the data attributes for the IRIS dataset. That is, first of all, what I did is from sklearn dataset import data.iris. Here I have imported IRIS data from sklearn library. Also, I have imported the pre-processing from sklearn library. Then what I did, the process is similar, only the difference is in the last function that is used here, but I'll explain everything. Then I loaded the IRIS dataset into the variable IRIS. Then I printed the iris.data.shape, which we got as 150,4. Then what I did is I again separated the data and target attributes. Then I performed standardized that is scaling operation on data attribute. So I kept standardized underscore x is equals to pre-processing dot scale x, and then I printed the standardized values of x. This was my first question. Now moving back to PPT. Let's move to the second question. So my second question was I had to mention the characteristics of a good data model. A good data model should be accurate, adaptable, simple and scalable. That is, when we process a data, we have to make it more understandable. Thus a good data model should be accurate. That is, we should be able to predict the outcomes accurately, at least they should be near the accuracy. Then it should be capable of scaling the proportion to changes in data. That is, means it should be scalable. That is, as the data is changing, it should also change itself. Its range should also change. It should be understandable to the clients. In order to make out of anything, we should understand what we get. Normally the data is pre-processed in order to make it more useful. So if the data is more understandable to the clients, it's a good data. If it's not, then it's like worthless data. There is no meaning of pre-processing it, right? So the data should be understandable. It should be adaptable and responsive to the changes that take place during the time, because see, the data won't be same with time. The data will vary. Thus the data should be accurate, adaptable, simple, and scalable. So moving on to the third question. The third question was, I was asked about cumulative distribution function. Cumulative means it's a some collection of something, right? Cumulative distribution function f of x is represented at probability of all the values of x less than capital X, where capital X is the probability of random variable x. Okay, so for example, if we are asked to calculate the probability of a cumulative distribution function of a dice, and where capital X is 2, small x is 2, so it will be 1 by 6 plus 1 by 6, that is equals to 2 by 6, that is equals to 1 by 3. That is addition of everything for discrete random variables. See, the cumulative distribution functions are of two types, the continuous one and the discrete one. The continuous ones have continuous data, but for the discrete ones, the data is discrete. So the values of cumulative function will change with the values of x. So that you will be seeing in the next slide. Okay, so in this slide, we are asked we are seeing the discrete random variable. So discrete random variable means we get like on a x-axis, for every value of x, like x is representable. They are discrete values. They are not a combined value that is a curve. It is not like that. It is just a discrete value where, and if see, suppose suppose the small x is defined from small so x1 to xn, suppose, sorry, xj to like x1 to xn, then what will we do? If the value of x, that is the changeable value of x, that is the random value, if it's less than that x, then what will happen is it will be 0 if it is between minus infinity to x1, and if it is between x1 to positive infinity, that is the probability will always be 1, right? Yeah, and if it is in between them, then it will be summation, as we did for dice. What we did is we added the both, so it will be summation j is running from 1 to n, probability x to xj for x1 less than x less than xn. Moving on to the next slide, properties of CDF. So the first property of CDS is every cumulative distribution function f of x is non-decreasing. This is because since f of x1, if f of x1, fx of x1 is less than fx of x2, and if x1 is less than x2, then we say that fx, that is cf, is monotone and it is not non-decreasing function. Also, if CDF function for some value of x has a maximum value, sorry, the value of a function at maximum of x is 1. This is because for all the values, like if x is a maximum value, and then if and we have to take a summation of all those values that are beyond it. So if we try to take summation of all those values that are behind it, then it will be equal to 1, because it's like a complete set of all the random variables, right? Also, since CDF deals purely with probability, its values range from 0 to 1. Moving on to the third part, methods to calculate CDF, right? The first method to calculate CDF is using histogram, and the second method is using the sorted data. So let's move on to the coding part. Moving on to the coding part, we get question number 4. No, sorry, seriously sorry. Actually, it was question number 3. So this actually there was some history. I'm so sorry for that. So this is the question number 3rd part, defining the libraries. Okay, so first of all, what we did is we imported numpy as np. We imported matplotlib.py plot as plt in order to plot graphs. We also imported pandas, then percent matplotlib inline. Then what we did is we took like number of data points. So we as randomly, and on a random scale we took it as 500, and then what we did is we took the data of some random values, like for 500 values some random y variables. Okay, and then we have plotted a histogram. This is because we are finding the CDF using histogram, right? So first of all, I drew the histogram as such using matplotlib. Then what we did is we are just taking the data out from histogram, right? It means we are just taking the data out from histogram, like for each and every value. Then what we did is we found out the probability density function of histogram using count values, and then using numpy using numpy cum sum function, we calculated CDF, and then using PDF values by looping and adding, we can also find PDF like looping and adding, but here we simply use the function in order to make it more simple. Okay, so moving ahead, what we did is we have plotted a graph with bins count 1 PDF, and between bins count 1 semicolon, like nothing, then PDF. Then we marked the color as red for PDF, and we labeled it as PDF. Okay, and then we plotted another graph where it was for CDF, bins count 1 colon, and then we labeled it as CDF, and then we plot legend. So this was the graph that we got. Then moving on to the second part, that is method 2, using sorted data. Defining the library functions. First of all, we defined the library functions. As usually we imported numpy as np, matplotlib.py plot as plt, import pandas as pd, modulus matplotlib inline. Then number of data points used as usual 500. Then what we did is we took some random values for that, for all those values on x-axis we took some random values on y-axis, and then what we did is we sorted the data. There we drew histogram, but now here we have sorted the data. Okay, then just a sec, sorry, I'm really sorry for that. Actually it moved ahead. Then what we did is we found the values of we found the CDF values of y. After finding the CDF values of y, we plotted a graph of x and y, like x we plotted a graph of x versus y, and then we gave it a title CDF using sorting the data. plt.plot is a function that we use to plot a graph, and then we have plotted it. And this is the scatter plot we got. That's it. This was the third question, right? So moving back to PPT. Moving on to the fourth question that we were asked to choose on ourselves. So it was, I choose the portion data visualization, which is a bit easy part, and in this I intentionally chose matplotlib, pandas and seaborn because these are the most important libraries and are the base of that. Also, then let's move on to data visualization. Data visualization is graphical representation of data, right? It sounds like, okay, the definition, but it's like, imagine like if you are given a table and you have to memorize the things. Instead, if I gave you a graph, you will be able to remember and find the patterns in it. Rather than table, graph are easy to visualize and learn. So what we do is we visualize the, like, whatever it is written on in an array, in a table or anything, we just draw it in, like we just represent it graphically. So, what are the advantages of data visualization? First of all, data visualization helps us to quickly interpret the data and adjust the variable to see its effect. Data visualization helps in observing the patterns, anomalies, and exceptionals, and it is easy for interpretation. There are various libraries offered by Python which help in data visualization. Each of it has diverse features like Matplotlib, Pandas, Seaborn, ggplot, and Plotly. So first of all, let's move on to Matplotlib. So Matplotlib, here I have mentioned the important features of Matplotlib. That is, it is used for 2D. It is a 2D plotting library, and it extensively uses NumPy and other codes. It is a 2D plotting library. That is, graphs are produced. That is, the graphs produced will have only x and y axis, no z axis, because if z axis comes, it will be 3D, and Matplotlib won't be able to plot it. So it is purely 2D, only x and y axis. It produces a good quality of pictures, although it is originated for MATLAB, but it has nothing, it is independent of MATLAB while we use it. Also, it has heavy use of NumPy and other extensive code which provide good performance even for long arrays also. Moving on to the next topic, that is pandas. So for pandas, it was built on Matplotlib. It has higher level of API than Matplotlib, due to which we don't need to write long number of codes, right? In small number of codes we can do anything. It provides high level of data structures and functions which makes working it easy with heterogeneous data, like the data that are not of similar types, right? Means like something in integer, somewhere float, like that. It makes it easy for us to express it fast, and it's easy for us to gain it also. It is also used to make data analysis and data cleaning easy. Like pandas makes data cleaning easy, because whenever we get a data from real life, that the data from the real data has a lot of noise in it, and in order to clean it, there are very much hectic things that we need to do, but pandas has made it very easy. So moving on to Seaborn. Seaborn is based on Matplotlib as well. It is used to plot graphs. It provides high level of interface for drawing attractive and informative statical graphics. It sounds a bit tough, but let me tell you, it's kind of a level above, a level beyond, and the graphs that it draw are really attractive and are very much like accurate. Also, it is used to visualize random distributions. It supports pandas and NumPy structures. It is used for plotting graphs from given data set. Moving on to scatter. So let's move on to scatter plot. Scatter plot is a type of graph in which we represent a value. For example, there is a value of x for which there is some value of y. Like for x1 there is y1, so we represent it by plot. Then for x2 there is some y2, so we represent it by dot. Right. So like scatter plot is basically the graph of dots, as you can see here clearly in the diagram. Oh, sorry, just a sec. Okay. So I'll continue with scatter plot, then we'll come to histogram. So it is a set of points that represent the values obtained at two different variables plotted on a horizontal or vertical axis. It is useful for examining the relation between two-dimensional data series. For example, this is x and y axis. There is some for some value of x1. For data set 1 there is some value of y11, and for data set 2 there is some value of y12 for x1. So we can, and for if we get the series of data, then we can easily visualize the pattern and compare them. Okay, like from where it went, where the slope from where the slope of data set 1 was more than data set 2, then from where it was less, etc. And then moving on to the histogram, right? Sorry, we'll move to the code. So code is here. It's like question number 4, matplot. First of all, we'll see everything by matplot, and then we'll see by seaborn. Okay, so first of all, scatter plot by matplot. So here I'll explain a few things from beginning. See, the data that are imported are same data in Matplotlib as well as in Seaborn. So I'll explain it here. First of all, we have imported pandas as PD. Then we imported matplotlib.pyplot as PLT. Then we imported numpy as NP. Then what we did is we have a toyota.csv file, okay, that contains the information of cars, right? So what we did is we read that csv file. So the format for it is like we took a random variable cars underscore data, then pd like pandas dot read underscore csv, and in bracket we have to give single inverted, and in that inverted we have to write the address where the file is located, okay? And wherever the values are 00, we have neglected them. And then what we did is we just displayed the head of the cars data, okay? Then we represented the shape of car underscore data dot shape, that is we got the array dimensions, the 2D array dimensions. Then beneath it we took dropna axis is equals to 0, in place is equals to true, and then we again drew the shape after some operations. Then coming to the scatter plot, for that we use the functions plot dot scatter cars underscore data age, this is because we want to take it on x-axis, cars underscore data price, that we want to take it on y-axis, and the color of graph that we want it as red. Then we put the title as scatter plot of price versus price versus age of cars. So price versus age in months of cars. So x label was x, we labeled x as age in months and y as price in euros, okay? And the graph was plotted as such. Okay, now moving to the graph, scatter plot graph using Seaborn library, okay? So moving on to the scatter plot graph using Seaborn library. So just note down the key, like you can just take out the key differences. Like here we have imported as like Seaborn as CNS. I don't think the rest there is a bit like importing is like, first of all we imported pandas as usual. We imported matplotlib.py plot as PLT, then we imported numpy as NP, then we imported Seaborn as SNS. Okay, now what we did is we we stored the CSV file, right? We have the CSV file toyota.csv. So what we did is we stored that, we read that CSV file into cars underscore data, that is here. So pandas pd dot read underscore csv, and then the address of the file, and then na values. Then we just displayed the head of the cars underscore data, then we displayed the shape, and then comes the scatter plot. Here what we did is like SNS, that is Seaborn dot set style is equals to dark grid, then SNS dot reg plot x is equals to car underscore data age, right? Age from car underscore data, right? Y is equals to price from car underscore data, and then the graph was plot as such. Okay, now moving on to PPT again. Let's move to histogram. Histogram is it's like, it's easy, but it's like it is it has bars that have values in ranges, like means it will have it is representation of data using bars of different heights. Okay, it represents, its group represents numbers into ranges, and the height of each bar, that is the length, yeah, the height of each bar, it represents the frequency of each range or bin. That is, one range is like from 0 to 1, it is a range, or from 0 to 3, it is a range. And then the height is its frequency. Okay, I think you are getting it. Okay, then to represent the frequency distribution of numerical variables, it gives discrete display of value frequency, like it gives discretized display of value frequency. Like you can see here, like it is discretized display, like from 0 to 2 it's 0 to 1 it's like something for like for 5, then from 2 to 3 it's like 15. So it's, they are like discrete values, they're not continuous. So moving on to the code, uh, here it's the code for, first of all, by matplotlib. So histogram, just a sec, histogram. So like the code for histogram is like, first of all we'll have to import all these things that we did here, like import pandas as pd, import matplotlib.py, plot as plt, import numpy as np. Then we'll have to read the data dots csv, we have to read the csv file into cars underscore data. Then comes the thing. Okay, so where is it? Just a sec. Yeah, this. So what we did is plt.hist, because histogram, the function hist, there cars underscore data and its kilometer. The we have plotted the graph of kilometers. We have, so it's for a, just a sec. It's for price versus kilometer, I guess. So we plotted the graph of this versus kilometers, and like number of cars that like for example like six cars ran from 0 to 20,000, right? Then from 20,000 to 40,000 kilometers, like around 7 cars were driven. As such, the plot is this. Okay, now moving on to the plot by SNS. Okay, actually it's an age, the both the graphs are different. It's age versus it's the number of cars along with their ages, right? See, the age is like from 0 to 10, right? Let's come to like age is like 23. Okay, so this is the age graph. So cns dot dist plot, since it is seaborn library, the functions will change. Dist for histogram, it's dist plot cars underscore data, the age, and then kde is equals to false, and we got the graph, that is histogram, right? This is the age of the vehicles. Then moving on to the next, that is coming back to ppt for bar chart. Like just let's see, bar plot, right? So it represents it presents categorical data in rectangular bars. Okay, bar plot is a plot that presents categorical data with rectangular bars with length proportional to the counts they represent. For example, if it is 4 centimeter long, then it represents the count, that is for 1 it is 4 or it is 10. Then for 2 it's, if it's 8 then it's 20, the count is 20 if it's 8 centimeter long. As such, it is generally used to represent the frequency distribution of categorical variables. The bar diagram makes it easy to compare the sets of data between different groups. That is like we can easily compare. For example, if we draw a grouped bar plot, then what will happen is we'll be, for example, for one, like for data set 1 the value is 2, for the data set 2 it's the value is 3, then for 2 for data set 1 is 10 and data set 2 is 3, like, and as so forth. Like we can, like each and every like minute details can be observed on a bar plot. Let's move on to the code. So code is here, the bar plot. This is I think Seaborn. We'll first see with matplotlib. So bar graph. So here we have first written the array for counts. Then fuel type we wrote it as petrol, diesel, and CNG. As you can see in graph, just a sec. The graph is frequency versus the fuel types versus frequency, right? So fuel types we have mentioned it as 929, 120 and 12, that is y-axis. The fuel types count is 929, 120 and 12 on y-axis. Fuel type is petrol, diesel and CNG on x-axis. Then we gave index is equals to np, that is numpy dot arrange length of fuel type, right? Then what we did is we plotted bar plt dot bar, then we use the index variable here, then counts, that is x-axis, and then we use the colors. The index represent the length of the fuel types, so the y variable, the x variable, and the color of that we want. So we choose yellow, red for petrol, yellow for diesel, and blue for CNG. Then what we did is we just like it's our choice to mention it or not. We wrote title like plt dot title bar plot of fuel type, then plt x label fuel types, then y label frequency. Then we plotted the graph, and this is what we got. So this was with the help of matplotlib. Then we'll be just doing similar things with the Seaborn library, right? So with Seaborn it's very simple. It's like sns dot count plot x is equals to fuel type, data is equal to cars underscore data, and we got the graph. And yeah, and the references. So the from where I got the information, first of all I used geeks.org, the most famous website that generally programmers and students use to get information. Then I used matplotlib.org to get the exact and detailed information. I used pandas.pydata.org to get the information, and I used the study material provided by college. Thank you.